Is the Earth going to be consumed by a black hole anytime soon? Luckily, the answer is no. There are no black holes within a distance from us that would prompt caution. But just because there are none near us doesn't mean we should completely disregard them. They can still potentially contain many answers that we are actively searching for within our universe, and our scientists are actively researching them every single day to learn more and more about them. So what is a black hole? A place where gravity is so strong not even light can escape. Now what does that really mean? Now a black hole's gravity is so strong that the light from my lamp is allowing you to see me. It reflects off of me and allows you to see me. If there's a black hole off camera right here, it would just consume all the light. So the light travels at 186,000 miles per second. This is very fast. This is the fastest thing in the universe. You cannot exceed the speed of light. And the black hole's gravitational pull is so strong, it pulls it in, and not even that can escape. Now, where does the name black hole come from? No light can get out, therefore we cannot see them. Because light enables us to see things and the black hole consumes all the light, we are unable to see it. It is invisible to us. So where is the nearest black hole? Gaia BH1 is the name of the nearest black hole. It is 1,600 light years away and it is 10 times more massive than our sun. So our sun is relatively a small star, so 10 times more massive than our sun is big. It's massive. So 1,600 light years away, what does that mean? Now, as we previously discussed, the speed of light travels at 186,000 miles per second. So that means if we were to travel at that speed for a full year, that counts as 1 light year. So if you were to travel at that speed for 1,600 years, that is 1,600 light years, that's how long it would take you to arrive here. So it's very, very far, and that's the nearest one. So this picture here is actually a real picture, is the first ever picture of a black hole, and it's actually this picture of Gaia BH1. Now I know in the previous slide I just discussed black holes are invisible. How do we see this picture? So this picture was taken through a special X-ray telescope lens, and what you see here highlighted is essentially the black hole consuming the matter. So it isn't the actual black hole you see, we just captured an image of it while it was consuming matter. So the highlighted point is actually matter, and it gives us a little outline look of what the black hole would look like. So next we want to discuss where do they come from. Now I've added the life cycle of a star here so we can get an idea. And it all starts off, as you can see, with the stellar nebula. Now, the stellar nebula picture isn't the best, so if we look to the left, we can see a real stellar nebula. Now, this picture is straight from NASA. This is called the Pillars of Creation, is its nickname. And I know it looks small, but it's actually several light years long. It is massive. It is made up of gas and stardust. And each little shining little bright you see there is actual stars. That's the size of this thing. So we can see it goes to an average star or a massive star. So the size is predetermined by how much, the gravity, how much matter the gravity pulls together. And a massive star can be 3 times more mass than our star. Our star would be considered the average star. So the larger the star, the quicker it burns out, and the massive star would start to expand at the end of its life, billions of years. It would expand into a red giant. And then the mass is so strong, no force in the universe can stop it from collapsing in on itself, and that forms our black hole. So now the fun part, what happens if we venture into a black hole? So somehow we were able to get there, even though it's far away. We magically were able to get there. So as we can kind of see the surface, you can see the surface of the black hole, just where the black begins. We call that the event horizon. So right now, everyone has an infinite amount of possibilities, right? Think of it as a branch kind of going out, within the next few seconds, you can wipe your eye, fix your hair, an infinite amount of possibilities. Once you pass this event horizon, the gravity is so strong, the escape velocity needed exceeds the speed of light. And as we learned, you cannot exceed the speed of light. So once you pass this point, you are going into the black hole. It is impossible to escape. All your futures condense into one, and that is you are going into the black hole. It's kind of interesting to think about. And then we have the singularity, which is the very center of the black hole, a point of infinite mass and infinite tiny space. And essentially, once you approach the singularity, the gravity is so strong, you will be pulled. It's a term astrophysicists use. It's called spaghettification. You will be pulled atom by atom into just a very long piece of spaghetti. And I know a lot of people like to theorize maybe it'll be, the black hole is a portal to another dimension or another universe. We do not believe that to be so, but even if it was, no matter would be able to survive the journey, so we would never know. And the last part here, we have black holes' effect on time dilation. Now this one can be tricky. So time dilation time is experienced differently. So on the right here, we have an actual picture of the gravitational effect on space and time. So as you can see, when you're traveling straight, you travel along the normal line. And in person, if you were looking at somebody as they're traveling along this curve, to your eyes, to your visualization, they would be going straight, but in reality, they're kind of going along this curve, and they would experience time dilation. Now, if I was to start my clock, my stopwatch here, and press start, and someone on this curve was to press start, when my clock watch hits an hour, or when theirs hits an hour, mine could very well be at a few days, right? So an example of this would be Sagittarius A, which is the most massive black hole in our Milky Way galaxy. And if you were to stand on the edge of the event horizon for just a few seconds of that black hole, 700 years would pass by here on Earth. So as Einstein's theory presents itself, time is not relevant. Time is experienced differently. And another effect this can have is black holes once were stars, so planets can orbit black holes, and these planets experience the gravitational time dilation of the black hole, so time can work differently on this planet. An hour on that planet can equal to a week here on Earth. So the black hole's time dilation effects are very interesting to take a look at. That's about all we have for black holes. So thank you for listening.